Welcome to another episode of Mastering Cybersecurity, developed by baremetalcyber.com. Let's dive in. To keep everything grounded, imagine a small web application that sells books for a neighborhood store, plus the home network of the owner who manages that store. The web app lets customers browse books, create accounts, and pay for orders through a simple payment page connected to a basic provider. The home network has a wireless router, a couple of laptops, and maybe a small network printer, all sharing the same internet connection. These examples are intentionally plain because they mirror many real situations in small businesses, student projects, or family households. When you picture the bookstore website, you can visualize pages for logging in, placing orders, and viewing account details. The home network includes a wireless password, default router settings, and devices that might travel between home, school, or work. This modest setting is enough to practice meaningful threat modeling without fancy diagrams or complex tools. Every concept in this episode will hook back to these very ordinary systems. A core idea in threat modeling is the asset, which is anything valuable that deserves protection in your system. An asset might be information, such as customer names and addresses, or it might be a service, such as the ability to place orders on the bookstore website. On the home network, assets include family photos, homework files, or access to online banking from a personal laptop. Thinking in terms of assets helps you avoid getting lost in technical details that do not really matter to the people using the system. When you start from assets, you always ask what needs to keep working and what must stay private. This perspective keeps security work connected to real impact rather than abstract technical worries. In threat modeling, listing assets clearly becomes the foundation for every later step. Without that list, the work usually drifts and important risks remain hidden. Once you understand what an asset is, the next step is learning to find concrete assets in your example system. In the bookstore web app, customer account details, saved addresses, and order histories each represent separate assets with different levels of sensitivity. Payment information handled by the payment provider is another serious asset, even if the bookstore never stores full card numbers, because misuse of that flow still harms customers and the business. On the home network, the wireless password itself is a surprisingly important asset because it controls who can join the network and see traffic. Shared folders on a laptop that holds tax documents or medical records also qualify as significant assets that deserve attention. Writing these assets in simple language helps everyone on the team understand what is at stake, including non-technical owners or managers. A common mistake is treating everything as equally important, which dilutes focus and wastes effort. A safer approach is to highlight the few assets whose loss would really hurt people or operations. Another key idea in threat modeling is the attacker, meaning any person, program, or process that can cause harm to your assets. The attacker might be a stranger on the internet probing the bookstore website for weaknesses, or it might be malicious software on a laptop inside the home network. In some cases, the attacker is simply an automated bot that blindly scans thousands of sites, not a human who knows anything about your bookstore. The important point is that attackers have goals, such as stealing data, interrupting service, or misusing payment features. When you think about attacker goals directly, you avoid cartoon images of criminals and instead focus on what specific outcomes they desire. This clarity makes the threat model more realistic and less emotional because it centers on actions and effects. A common mistake is assuming nobody would bother attacking a small site, which leads to neglected safeguards. A safer mindset accepts that automated attacks treat small systems as easy targets, not special exceptions. With assets and attackers in mind, threat modeling next looks at entry points, which are the ways someone or something can interact with your system. In the bookstore web app, entry points include the login page, the account registration form, the shopping cart, and the payment submission step. Each of these places accepts input from the outside world and passes it deeper into the system. On the home network, entry points include the wireless access point, remote management features on the router, and any exposed services on connected devices. Closely related to entry points are trust boundaries, which are the lines where control or responsibility changes, such as between the bookstore website and the external payment provider. Crossing a trust boundary usually means crossing from something you control to something you do not fully control. Recognizing entry points and trust boundaries makes invisible weaknesses visible because you see exactly where untrusted data first arrives. It also sets you up to reason about where additional checks or protections are needed most. Threat modeling also needs a practical definition of a threat, which is a specific bad thing that could realistically happen to your assets. A threat combines an attacker, an entry point, an action, and an impact on something valuable. For example, a threat might be an attacker sending specially crafted input through the login form to gain access to another customer account. Another threat might involve someone nearby guessing the weak wireless password and joining the home network without permission. Each threat should tie directly back to the assets you identified earlier, so the impact is clear and concrete. When threats remain vague, teams struggle to decide which ones deserve attention or how to address them. A common mistake is writing threats as extremely broad statements, like "hackers steal data," which loses all useful detail. A safer approach is to connect each threat to a specific path and outcome that you can actually check or test. To help beginners remember common categories of threats, many teams use a simple checklist called spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privilege, STRIDE. Spoofing covers threats where someone pretends to be someone else, such as logging in as another customer by guessing their password. Tampering involves altering data or code, like changing a price in a shopping cart before checkout succeeds. Repudiation refers to situations where someone can deny performing an action because the system lacks reliable records. Information disclosure includes accidentally or intentionally exposing private data, such as shipping addresses or order histories. Denial of service problems make the system unavailable, perhaps by overloading the bookstore site with traffic. Elevation of privilege means gaining more power than intended, such as using a normal account to perform administrative actions. Using STRIDE as a gentle mental checklist helps ensure you do not overlook important threat types while modeling. Once you have a set of possible threats, the next step is to think about likelihood and impact in simple, non-mathematical terms. Likelihood means how likely it is that a threat will actually occur, given how exposed the system is and how much effort an attacker must invest. A threat that requires specialized physical access to a locked room might be less likely than a threat based on a public web form that anyone can reach from the internet. Impact measures how bad the outcome would be for people and the organization if the threat happened. Loss of a single low-value test account probably carries lower impact than theft of all customer addresses and order histories. Beginners do not need formulas to reason about likelihood and impact, only honest discussion and basic comparisons. A common mistake is either treating all threats as equally terrible or ignoring unlikely but catastrophic risks completely. A safer balance ranks threats loosely, so attention goes first to problems that are both realistic and seriously harmful. A powerful but simple practice in threat modeling is writing clear threat statements that combine attacker, entry point, asset, and impact into one understandable sentence. For the bookstore, a threat statement might say that an internet attacker uses the registration page to create many fake accounts, overwhelming the system and preventing real customers from signing up. Another threat statement could describe a nearby person guessing the weak wireless password, joining the home network, and capturing unencrypted traffic from a laptop. Writing threats in this structured style keeps the team focused on real paths and real consequences, not vague fears. It also makes discussions with non-technical stakeholders easier, because each sentence describes a story they can follow. A common mistake is using technical shorthand that hides the human impact, which reduces urgency and understanding. A safer alternative keeps language plain and complete, even when the underlying mechanics are complex. After expressing threats clearly, you can start thinking about mitigations, which are practical ways to reduce likelihood, reduce impact, or both. A mitigation might involve stronger authentication on the bookstore site, such as requiring longer passwords and enforcing protections against repeated login attempts from the same source. Another mitigation could be configuring the router to use modern wireless encryption and a long, unique password that attackers cannot reasonably guess. Sometimes mitigations involve monitoring and logging so that suspicious patterns are noticed quickly, which can reduce the duration and impact of an incident. Good mitigations tie back to specific threats, so the team can explain exactly which risk is being addressed and how. A common mistake is applying generic security measures without linking them to particular threats, which leads to gaps and wasted effort. A safer path chooses a mitigation only when the team can describe the matching threat statement it helps control. Threat modeling is most effective when different roles use the model in ways that support their everyday decisions. Developers working on the bookstore website can use the threat model to understand where input validation, authentication, and logging matter most along each path. Security defenders can use the same model to design monitoring rules and incident responses aligned with the highest impact threats. Managers and owners can lean on the threat model to justify security investments, focusing budget and attention on risks that actually threaten important assets. When the home network is included, family members or small business staff become part of the conversation, learning which behaviors protect shared systems. A common mistake is treating threat modeling as a one-time expert exercise that nobody revisits. A safer approach treats the threat model as a living summary that guides design choices, operational practices, and reviews whenever the system changes. Another important habit is keeping threat modeling calm, repeatable, and right-sized for the system you're analyzing. For a tiny bookstore website or home network, a short session with a small diagram and a handful of written threats is often enough to reveal useful improvements. Trying to catalog every possible threat at extreme detail can exhaust people and produce documents nobody uses again. Threat modeling works best as a regular activity that fits naturally into design discussions, code reviews, and changes to infrastructure. You revisit assets, entry points, and threats when features change, not only after something bad happens. A common mistake is believing threat modeling must involve complex tools and advanced mathematics, which discourages beginners. A safer mindset embraces lightweight, plain language techniques that support thoughtful progress without overwhelming anyone. Over time, practicing simple threat modeling builds a habit of seeing systems the way attackers might, while staying grounded and responsible. You recognize that every asset, from customer data to family photos, deserves conscious decisions about its protection. You learn to notice entry points and trust boundaries as soon as a new feature or device appears, instead of waiting for trouble. You become more comfortable judging which threats truly matter, based on realistic likelihood and meaningful impact. The process also encourages clear communication between technical and non-technical people, because threat statements and mitigations use shared, understandable language. Thinking like an attacker safely does not mean admiring harmful behavior. It means understanding how harm could happen so that it never does. This is Mastering Cybersecurity, developed by BareMetalCyber.com. Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.